So now that we talked about the first part of our ex2 case study, let's talk about part 2. So this is going to demonstrate a whole other slew of methods from the ex2 observable class in order to be able to create large random big integer objects in one thread and then asynchronously check to see if they're prime in another thread. So before we checked them all in the background thread from the computation scheduler that was running the interval time mechanism, and this time we're going to have them created in one thread and then processed in a different thread. And as always, you can find this example in the ex2 project in the reactive observable folder in my live lessons GitHub repository. So we're now back in the ex2 case study project for this particular example. And before we'd taken a look in part 1 at the test is prime timed method, and now we're going to take a look at the test is prime async method. Both of them, again, are registered with the async task barrier, and the async task barrier doesn't finish until both of those methods finish running. So let's go ahead and take a look at the test is prime async method. And what this method does is it uses an observable stream that processes random numbers to determine which ones are prime. And it's going to have some of the processing going in the background in one thread and some of the processing in another thread. So there's 2 threads involved in this particular example. So let's take a look at what we do. The first thing we do is we have a string buffer because we're going to be doing logging in multiple threads. We create a log consumer that will print where the actual operation is occurring, what thread it's occurring in. And then we go ahead and we use the create method on observable, except this time we're going to pass it a different emitter. This is called emit async. So let's go take a look at what emit async does. So emit async is going to bridge the reactive world with the callback style world of reactive streams to emit a flow of random big integers in a background thread. And here's how this is going to work. This is kind of cool. So we're going to generate max iteration integers starting from 1. So we're going to use the range long factor method to go from 1 to s max iterations. And once again, we don't really care about those values. We just want to generate n of these things, max iterations of them. And then we're going to use the subscribe on operator to arrange to emit the random big integers in a new thread, which I'm going to call the publisher thread, just to give you the context of where this is occurring. So all the computations starting from here are all going to run in this new thread. And then we're going to use the generate random big integer function to generate random big integers, as we did before, within a range, so we get duplicates. As before, we're going to omit even numbers from consideration, since they certainly could not possibly be prime. And then we're going to use the subscribe method that doesn't block to say when things go well, emit that value from this background thread up to the other chain that comes out of the create method. And if things go wrong, complete. If things go right, but we're done, complete. So that's how we terminate the stream. So let's go back here. You can see that that's how we emit the values in a background thread. Now we go ahead and print the value in the background thread to say what's happening. So when we look at the code, you'll see that items are emitted and printed in the background. The next thing we do, and this is where this example starts to deviate from the previous one, we're now going to use the observe on scheduler method to tell the observable stream to run the rest of the operators in the stream in a new scheduler thread. So that's a different scheduler thread from the other thread, the one where we're publishing. This is going to be the subscriber thread, if you will. So we have one thread that's publishing, generating those random big integers, and another thread, this thread, that's going to be subscribing and handling, observing them. The rest of the code looks very similar to what we did before. However, we check to see if the value is prime using the checkIfPrime method, which we looked at in part 1 of the video. When we determine the primality of this thing, we will process the results, get the results here. And then we add a doFinally hook that will display the results after everything is done. Now, with the previous example, just to be different, we used the doOnComplete method, which does effectively the same thing as long as errors don't occur. If errors occur, that doOnComplete method would be skipped. doFinally will always run even if an error were to occur. We don't have an error in this case, but just to be aware of how they differ. And then the last thing we do, this do on finally, of course, displays the results. And the last thing we do is we use the ignore elements method to return a completable that the async task barrier framework uses to synchronize so it knows when this particular asynchronous operation is done. And recall that when all those operations are done, then in that particular case, blocking get will return and the operations will be finished. The main program can exit. Okay, so let's just kind of pop back over here real quick and look at the results. So these were the results we looked at before for test is prime timed in part 1 of this video series. Everything ran in this background thread, just the one thread, and it ran at intervals every half second. Now we've got the results from test is prime async. And you can see it's a little different. First of all, you'll notice that things just run as fast as they can, where it's not waiting a half second between emitting the events. Secondly, you can see that the emissions are taking place in one thread, one scheduler thread, which is different, by the way, from the computation thread pool, which is where the interval method ran. These things are all running in a background thread. But the checking to see if something's prime is actually running in a different thread. So Rx new thread scheduler 1 is the publisher thread, and Rx new thread scheduler 2 is the subscriber thread, and it's emitting in the publisher and then checking for primality in the subscriber. And again, this will be clever and will make sure that it does the right thing. And you'll notice here also that we only took odd numbers. So if there were few odd numbers, it would basically not, even numbers are swallowed, I guess is the right thing to say. They're suppressed by the use of that filter operation that we saw before. Okay, so just kind of interesting. This one, as you can see from looking at the times, dumps the values out as quickly as they can. This one, in contrast, delays a half second between each of the calls. So that's the end of case study ex2, kind of illustrating how you can apply all these more advanced features from RxJava, such as the create method that can have the publishers running in one thread and subscribers running in a different thread or different threads. You can also see how we can chain things together by using suppressing operators like filter and ignore elements. You saw how ignore elements could be used to be notified when something is done. You saw how do finally and do on complete are called to know when a stream is finished processing. And so this example is just a lot more interesting and a lot more comprehensive and realistic than case study ex1, which didn't use the concurrent processing features whatsoever.